In this section, we're going to talk about logarithmic functions and their graphs. So first of all, you have to keep in mind that these functions are inverse of exponential function. So they are based on exponential function. So first of all, let's say you have an exponential function 2 to the power x. So it's going from input to output, and then function is 2 to the power x. So 1 goes to 2 to the power 1, 2 goes to 2 to the power 2, and then so on, so on. So as you can see, the graph of exponential function is 1 to 1. So going back process is possible. And that going back process is called logarithmic function because the exponential function has a base. So the way we define is going back function, which is a reverse or inverse of exponential function with the base 2. So we denote this way. LOZ stands for logarithmic function, which is the reverse process of exponential function. And in this particular example, there is an exponential function with the base 2 used. So whenever we have that base, we use log base 2. And then this inputs comes from here. So this is just the notation, log base 2. That means it's a reverse or inverse of exponential function 2 to the power x. So we're going to talk about some common bases. For example, base 10 and base e. We're going to convert the exponential equation to the log and vice versa. We're going to use calculator to calculate the value. We're going to change the logarithmic basis. And then finally, we want to plot the graph and solve the application problem. So logarithmic function are inverses of exponential function. So if you have exponential function y equal 2 to the power x, and if you want to find out the inverse of this, then just change this x by y and y by x. That's what happens in inverse. You just switch x and y coordinate. Now from this equation, choose a value for y and compute the value for x. That's how you get x and y coordinates. For example, let's say if you choose y equals 0, then here x would be 2 to the power 0, which is 1. So 1 comma 0 is one of the point. If y is 2, x would be 4. If y is 1, the x would be 2, and so on, so on. So you are going to collect all those. Okay, here. Okay, so here you have one example. This is the graph of 2 to the power x, and by just switching the x and y coordinate, we can find the graph of this one, which is actually the graph of log base 2 of inputs y equal. And you can find the points by solving this equation. Okay, don't worry about this. I was doing one of the problem from the assignment, so I forgot to erase this. Don't worry about that. Okay, so we can now define log function with a base a, and this is the notation. Okay, and that is we can find the value for the graph of this function by using this equation. Okay, and how do we read it? We say the logarithmic function with the base a of x, logarithm base a of x. That's how we read. Okay, if you go over the log function, you always find the value of the log function no matter what base you pick. At 1 would be 0. Okay, log base, any base at 1 would be 0, because in exponential function at 0 the value would be 1. So this is always true. If you try to find the log base a of a itself, if these both bases are equal, the value would be 1. And there is a equivalent expression log base a of x is equal to y can also be written as x equal to a to the power y. Okay, so if your base of the log function is e, then this is the notation we use, and that's called natural base, lnx, natural logarithmic function. If the base of the logarithmic function is 10, then we just use log. We don't write down anything base. So if you don't see any base, that means the base is 10. There is a way to change the base of log function, because what happens is when you try to use a calculator, especially scientific calculator, you'll be able to see the log like here, log or ln. Log means a log function with the base 10, and ln is the log function with the base e. So if you have to compute, let's say log base 2 of 5, then there is no way we can use the calculator without changing it to the different base. So this can be written as log base 5 divided by log base 2 using this formula, and now we can use a calculator to approximate the value. So these are some information about the log function. So let's look at some problem here. This we would like to plot the graph of this one, which is the inverse of 2 to the power x exponential function. So this is the 2 to the power x. Its inverse is the reflection across the y equal to x line. So it's supposed to be this one, which is the log function. Okay. Here the base is half, which is less than 1. So original function, the original exponential function has to be like this. Then inverse of this would be look like this, because it's supposed to be reflection across the y equal to x line. And you can find all these points by choosing the value of y and calculating the value of x for different y's. So this would be the answer. Okay, let's go to this one. What is the log base 3 of 81? So actually what you are asking yourself is, let me so whenever we try to solve this type of problem, we would like to find out what is the value of log base 3 of 81. Actually, we're asking this question, 3 to the power what value is 81, because it's a reverse of 3 to the power x function. So this is the question we're asking. So 3 to the power 4 is 81. So the answer for this one is 4. Okay. Another way you can calculate the very same thing by using the calculator, log 81 divided by log 3, and let's see what happens. Log 81 divided by log 3, log, where is that? Sorry about that. 81 log divided by parentheses 3 log parentheses close equal, and the answer is 4. So what is the answer? Answer is 4. Okay. We would like to plot the graph of this one. The base is 9, so this is the reverse of 9 to the power x. So reverse of the 9 to the power x would be this one. Why that one? Because if you look at the graph of a standard graph, for any base greater than 1, this has to be the nature. And that's the only graph we have which is similar to that base. Find the log function 5 to the power what gives you 625. That is the question you are asking yourself. 5 to the power 4 gives you 625. Log 1/10. So problem like this, whenever you try to find the log function, you try to express log a things inside the parenthesis. If you can express it as a to the power x, then this base and this base cancel out, then answer would be just x. So here the log has the base 10, Can I write down this 1 over 10 as a 10 to the power negative 1? The answer is yes. Because they have the same base, the answer comes from the exponent, which is negative 1. You can also use your calculator to calculate this value. Convert to the logarithmic equation that has the same meaning. So this is the exponential. So log equation, we would like to go from, where is that? This one to this one. So just write down P, X is P, A is E, Y is negative 2. So if you want to write down that as a log function, then that's supposed to be log base E, because the base is E here. X means P equal Y is, what is Y? Y is negative 2. So log base E is actually ln P equal negative 2. So that's supposed to be ln P equal negative 2. That's the log expression. Convert to the exponential function. Ln 85 is, so exponential would be the base, where the base is E to the power, this value is 85. So base to the power, the power comes from here, which is 4.4427, is equal to the value comes from inside the parentheses, which is 85. Log negative 19, use a calculator, so you can just use, what is the log? No, first type negative 19, so 19, negative, and then log. The value is invalid because the log function is not defined for the negative value, because the input of the log function comes from the output of the exponential function, and output of the exponential function is all positive number. Okay, that's all for this section.